So today we'll be solving questions of ship stability that involve the concepts of deadweight, TPC, that's tons per centimeter immersion, and reserve buoyancy. So I'll solve different types of questions in this area, and as we come across the terms, I'll also explain the terms for you. All right, so let's start with question number 1, which says that there is a box-shaped vessel which is 120 meter long and 16 meter wide. That's the length and the breadth, and it has a load draft of 8 meters. If her present draft is 6 meters, find the dead weight available, or DWT stands for dead weight. All right, so let's understand the question first. So the first sentence is pretty straightforward, that there is a box-shaped vessel which has a length of 120 meters long and 16 meters wide. All right, and it has a load draft of 8 meters. Her present draft is 6 meters, and you have to find the dead weight available. So to find the dead weight, you must understand what is dead weight. So the dead weight of a ship is actually the total mass of cargo, fuel, fresh water, and anything else, etc., that a ship can carry when she is floating in salt water or seawater with her submerged load line at the water surface. Alright, so you know there are load lines on the ship. So if I look at the port side of a ship and I see the load line, you know that the load lines on the side of a ship look like that. So tropical freshwater, then tropical, and then sea, and then W. This is winter, right? So this is the summer. S stands for the summer load line. So that means if this is a ship's port side, all right, so the water is up to here till the summer load line. This is the summer load line. Alright, so for those of you sailing on ship, so this is the port side of, I'm just giving an example of the port side. So dead weight, or the formula of the dead weight, then becomes the load displacement minus light displacement. So what does that mean? So load displacement refers to the total mass of the ship when she is floating in seawater or salt water with her submerged load line at the water surface. Alright, so relative density of salt water is 1.025, and light displacement stands for mass of the empty ship, which does not have any cargo, fuel, oil, ballast, water stores. So that's why dead weight then refers to the mass of the cargo, fuel, fresh water, and anything else that a ship can carry to bring her up to her submerged load line, but when she is in sea, or salt water rather, of relative density 1.025. Alright, so that's why dead weight is equal to load displacement, total mass when she is floating in salt water with a submerged load line, minus the light displacement, that is the mass of the empty ship. And then you know how much you can carry to bring her up to that level, right? So displacement, which is denoted by W, if you have watched my previous videos, this is displacement. Displacement, the calculation formula is underwater volume. This stands for underwater volume. So this UVW stands for underwater volume multiplied by density of the water displaced. So in this case, your load displacement is 120 by 16 by 8. So this is length by breadth by load draft. Alright, because that's your draft up to the submerged load line, multiplied by the density of seawater, gives you the load displacement. Your present displacement is 120 by 16 by 6. This is your present draft. 6 meters is your current draft or present draft. That's why your present displacement will be length by breadth by your current draft multiplied by density of the seawater, which gives you your current displacement. Therefore, the dead weight available, or the amount of cargo, fuel, freshwater, etc., that you can carry, will be load displacement minus current displacement, that is 15744 minus 11808, which gives you 3936 tons. That's your dead weight that you can now carry. Alright, Let's go on to the second question, which says that the length and breadth of the water plane of a ship are 100 meters by 12 meters. If the coefficient of fineness of water plane is 0.7, find her TPC in seawater and freshwater. So there are some terms that are used here that you are probably not familiar with. So let me explain those terms first before I start solving the question. Alright, so water plane coefficient, or which is denoted by C and in the lower CW, alright, or coefficient of fineness of the water plane. These are the same terms, right? Is the ratio of the area of the water plane to the area of a rectangle having the same length and maximum breadth. Alright, so over here you can see the figure which shows you what do I mean. So coefficient of fineness of the water plane, or water plane coefficient, which is denoted by C under stroke is W, is the ratio of the area of the water plane, which is can be seen here by the shaded here, to the area of the rectangle having the same length and breadth. Alright, so you can see in this case the rectangle has the same length as the water plane area and maximum breadth. So coefficient of fineness of the water plane area denoted by C with an understroke of W equals the area of the water plane divided by length by breadth. From above you can see that. Therefore area of the water plane in this case will be equal to length by breadth of the rectangle having the same length and maximum breadth multiplied by water plane coefficient. So basically you have taken this one here. Alright, so that is one definition and it has been given to you. So the value of the coefficient of the fineness of the water plane is given to you in the question as 0.7. The length and breadth is also given to you as 100 by 12. So you have all this information available to you. But you have to find something called TPC. What is TPC? TPC stands for tons per centimeter. This is the number of tons required to cause the ship to sink or rise by 1 centimeter only. So this is the keyword. 1 centimeter is the keyword. That's the number of tons required. Therefore the SI units of TPC is tons per centimeter. Alright, so this is the number of tons required to cause the ship to sink or rise by 1 centimeter only. So let's start solving the question. Like I said before, the water plane area, or the formula for the water plane area from here, is length by breadth by coefficient of fineness. All three values are given to you in the question. Put those three values in the formula and calculate your water plane area. Because it's area, your unit will be meter square. Then the formula for calculating the TPC is area by 100 multiplied by the density of water. You have just calculated the area. So TPC in salt water or sea water with a relative density of 1.025 can be calculated as 840 divided by 100 multiplied by 1.025. The same formula is applied here. And then you get your TPC. That means this is the amount of tons required to immerse the ship by 1 centimeter in seawater. And then use the formula again here to calculate your TPC in fresh water. It's the same thing, 840 by 100, area by 100 multiplied, only the density will change because density of fresh water is 1. And this is the amount of tons, 8.4, which is required to sink or rise your ship by 1 centimeter. Then we go into the next question, which also has some different concepts. So the question here says that a box-shaped vessel again is 120 meters long and 14 meters wide, and the height of the vessel is also given as 12 meters. Her displacement is 13,776 tons, and you have to find something called the reserve buoyancy percentage in seawater. Alright, so remember when you are solving questions like this, just make sure you highlight or underline the key information given to you and you understand the meaning of all the terms before you start solving the question. Once you understand the meaning of the terms and you make a note of the information given to you, it's just a matter of putting the values in the formula. The formulas are given in the book, or your lecturer might give it to you in the exam, or you might have to memorize it. I'm not sure how it works, But once you get the values and you understand the meaning, it's just a matter of putting the values in the formula. Alright, so the only term here that we don't understand is the term of reserve buoyancy. What is reserve buoyancy? So reserve buoyancy is the volume of the enclosed spaces on a ship which are above the waterline. So a ship will have enclosed spaces, a lot of enclosed spaces. Some of them will be above the waterline, some of them will be below the waterline. But reserve buoyancy refers to the volume of the enclosed spaces above the waterline. So that basically means it is not below the waterline. So in case there is a any kind of bilging or any kind of flooding that takes place, those areas remain free of those bilging and flooding, and that provides the ship with extra buoyancy, and that's why it's called reserve buoyancy. So basically ship can still stay afloat if we can calculate those percentage of those volumes of enclosed spaces which are above the waterline. Alright, so when we go into advanced stages, you will realize how this is important when bilging takes place or when there is flooding or any kind of leaks on the ship. You will realize why this is important later on, but for now this much is enough. Therefore your reserve buoyancy, which is denoted by RB here, equals total volume of the ship minus the underwater volume. So if you subtract the underwater volume from the total volume, you will get the volume of the spaces which are above the waterline. Therefore reserve buoyancy percentage equals above water volume divided by total volume multiplied by 100. So let's start solving the question. You have been given the displacement of your vessel. Displacement is denoted by W. This is displacement. Again, if I am just repeating myself here, equals underwater volume multiplied by density of the water displaced. Now this be very careful with the density. So remember in what water you are, and then apply the appropriate density. So if it's fresh water, it's 1. If it's seawater, if it's 1.025. Other than that, the relative density of any other liquids or any other substances should be given to you in the question. Alright, so therefore displacement, which is 13776 given to you in the question, equals volume denoted by W, V, multiplied by 1.025, which is the density of seawater. Therefore volume equals, if I take this here, it will become division, 13776 divided by 1.025, which will equal 13440 meter cube. Volume is always in meter cube. Therefore total volume of the ship, again it's given to you, the dimensions are given to you as 120 by 14 by 12, length, breadth and height. Just multiply it, because it's a box shaped vessel, it's like a rectangular box shaped vessel. Just multiply the three values, you get the total volume of the ship. So you have the underwater volume here, underwater volume, and you have the total volume, right? All you have to do is now find the reserve buoyancy. So reserve buoyancy equals, you know from the above formula, total volume minus underwater volume. Just put in the values here and you get your reserve buoyancy, that is the volume of the spaces, and reserve buoyancy percentage will be equal to above water volume, which is 6720, and total volume, which is 20160. Divide them, multiply by 100 gives you a percentage. So 33.33% is your reserve buoyancy percentage. Reserve buoyancy percentage. Okay, and finally we come towards the last question, which says there is a ship floating in dock water. Dock water is denoted by dW of relative density, which is denoted by RD, 1.010. So here the density of the dock water is given to you. So if it's not fresh water and seawater, which are standard values of 1 and 1.025, the dock water density or any other water density will be given to you. So it's 1.010 at a draft of 5 meters. So draft is given to you. The length and the width of the ship is also given to you at the waterline. Her block coefficient or vessel's block coefficient is 0.72 and her light displacement is 1200 tons. Find the deadweight aboard. So you know the meaning of most of the terms here and we've discussed it. So we've discussed light displacement in the first question, we've discussed deadweight also in the first question. The only thing that we don't know here is block coefficient. What is block coefficient? So let's understand the meaning of block coefficient first. Block coefficient is denoted by C_B here, you can see that here, or coefficient of fineness of displacement. Alright, it's the same term. So block coefficient is the shorter form. at any draft is the ratio of the underwater volume of the ship at that particular draft to a rectangular box having the same extreme dimensions. Alright, so you see the difference between block coefficient and coefficient of fineness of water plane area. So coefficient of fineness of water plane area was talking about the ratio between the water plane area to a rectangular box having the same dimensions. But the block coefficient focuses on the underwater volume, not the water plane area, but the underwater volume, and divided by the rectangular box's dimensions of length, breadth, and draft having the same dimensions. Alright, that's why your block coefficient is different from coefficient of fineness of water plane area. So this block coefficient focuses on underwater volume and is ratio with the rectangular blocks having the same extreme dimensions. So again, displacement will be equal to underwater volume multiplied by density of water displaced. The underwater volume, as you can see in this formula here, if I take this here, the underwater volume will be equal to length by breadth by draft by block coefficient multiplied by density. Yes, so I got this from this formula here. So from here I got this here. Then putting the values of the length and the breadth and the draft is given to you, the block coefficient is given to you, the density is given to you as well. Calculate your displacement at that particular draft. So your displacement at 5 meter draft is 3272.4. You know that the dead weight is equal to load displacement minus light displacement. We have discussed this in the first question. Your load displacement is 3272.4 because that is the displacement at a particular draft, and the light displacement is given to you in the question, that is the mass of the empty ship. Therefore, the dead weight or the amount of cargo, fuel, fresh water, etc. that you can carry to bring the ship to her summer load line is 2072.4 tons. Alright, I actually have one more question for you. I thought that was the last question, so my apologies. The final question here says that a ship is floating in fresh water at a draft of 6.8 meters. So when it says fresh water, you know the density is 1. If her maximum, that's the density, in case you thought why am I writing 1 here. If her maximum freshwater draft is 7 meters and her salt water or seawater TPC is 40, find the dead weight available. So whenever you see so much information given to you, don't get stressed, alright? Like I told you before, once you know the formula, just write down the formulas that involve these terms and then see what you have and what you don't have, and then start putting the values of the things that you have and you'll figure out how to calculate it. So for example, in this case, I can see that the seawater TPC is 40. So the first formula I will take is seawater TPC. I know the formula, A by 100 multiplied by density. This is density. Alright, since let me write it nicely for you. So this is the density of seawater. If it was freshwater, I would have written the freshwater density. This is density of seawater because it's given to me that the seawater TPC is 40. So TPC is 40 given to me. Area I don't know, I have to calculate. Rest of the terms are given to me. So I will take this here, I will bring this down here. So area will be equal to 40 by 100 divided by 1.025, and I get my area. This is the seawater or salt water. Then the TPC in freshwater. Let me calculate. So again it will be area by 100 multiplied by 1. 1 is the density of fresh water. Alright, I'll write FW. Now you know this area. The area will be same, the water plane area. Put the area here divided by 100 multiplied by 1000 multiplied by 1.000, that's the density. You get the TPC, tons per centimeter. This is the amount of tons you require to sink or rise the ship by 1 centimeter. Alright, now you remember, so ship is floating in freshwater at a draft of 6.8 meter and her maximum freshwater draft is 7 meters. So she cannot go beyond 7 meters. And her seawater TPC is 40, find the dead weight available. So basically, you are already at a draft of 6.8 meter. You can sink the ship only by another 20 centimeters. So from 6.8 meters to 7 meters is about 20 centimeters or 0.24 meter. You have to find out how much weight you can put on the ship now to sink her by another 20 centimeters. So sinkage required is 7 meter minus 6.8. 7 is the maximum, this is the maximum one, and 6.8 is your current draft. So therefore you can only sink her by 0.2 of a meter or 20 centimeters. So 0.2 of a, because 1 meter equals 100 centimeters, so 1 meter equals 100 centimeters. Therefore deadweight available, or the cargo that you can load, or the cargo of freshwater all together that you can load, will be sinkage by TPC. Sinkage is 20 centimeters and tons per centimeter is 39.024. Or you can think about it like that. So TPC is the amount of cargo that you can load to sink the vessel by 1 centimeter. That is for 1 centimeter, but you need to find out for 20 centimeters. Therefore, if for 1 centimeter you can put 39 tons of cargo, which is your TPC, for 20 centimeters of sinkage you have to just multiply 20 by 39024 and you get your deadweight. Alright, so actually these are pretty simple questions. Alright, so don't get confused when you see so many terms thrown around you. Like I said before, if you understand these terms and if you know the formula, all you have to do is basically start putting the values in the formula. See what are the things you have and how can you find out the things you don't have. It's pretty straightforward. So if you understand the meaning of these terms and if you remember the formula, you should be able to do it. Alright, so if you have any questions regarding this these solutions that I did, please write to me in the comments, and if there are anything that you didn't understand, please feel free to comment as well. Alright, so I hope to see you soon with another video, and I keep thanking my subscribers and the people who follow me and write to me and give me feedback. I really appreciate it a lot. Alright, thanks guys, I'll see you soon with another video.